All right, so we're going to finish up section 13.7 in this video, and we're going to do a couple more exercises. So we are on page 873. And we're going to start with number 10, which says, in the exercise 9 through 12, approximate the number, and they give us 16.05 raised to the 1/4. So 16.05 raised to the 1/4 times 7.95 raised to the 2/3. 7.95 raised to the 2/3. All right, so in our last video, we did number 2, which they gave us a function and a point at which they wanted to approximate that function. This problem is identical to that problem, with the exception of they don't give us the function explicitly. We kind of have to figure out the function ourselves from the problem. And then they don't explicitly give us the point either. We have to figure out what in here is our point. But it should always be fairly straightforward to figure out what your function is and what your point is. So for this particular problem, the function that we're approximating, or we're coming up with a linear or tangent plane approximation for, will be f of xy equals x to the 1/4 times y to the 2/3, or some variant of that. You could switch your x and y or whatever. It wouldn't be something like 16.05 to the x times 7.95 to the y. Although you could attempt that, it's just way easier to use this function. Oops, I was about to change. That's the 1/4, and then y to the 2/3. And with that, the point xy then that they want us to approximate at is 16.05, comma 7.95, and then the point x naught y naught that we're saying is close to this point. The natural thing would be to use 16, 8. All right, so this is more typical of these type of problems where you're just given some expression and you're told to approximate that expression, and then you have to figure out what function you want to use and what point you want to use. Well, they're giving you a point in here somewhere. You have to figure out what point x naught y naught that you want to use. All right, so now the tangent plane approximation of the linear approximation of this function is f of xy is approximately equal to f of x naught, comma y naught, plus f sub x evaluated at x naught, y naught, times x minus x naught, plus f sub y evaluated at x naught, y naught, times y minus y naught. So we're going to find f of x naught, y naught, f sub x evaluated at that point, and f sub y evaluated at that point. Let's just start at f of x naught, y naught, so I don't forget that one. So f of 16, 8 is equal to 16 to the 1/4, times 8 to the 2/3, which is 16 to the 1/4, or the 4th root of 16 is just 2, and 8 to the 2/3, that's 8 to the 1/3, or 2 raised to the 2nd power. So this is just 8. All right, so then now we need the partial of f with respect to x. So the partial of f with respect to x is our y term is a constant, so that's not going anywhere. And then the derivative of the x term is 1/4 times x to the 1/4 minus a negative 3/4. And then y to the 2/3 isn't going anywhere. And now we need to evaluate this at the point 16, 8. So f sub x at 16, 8 is 1/4 times 16 to the 1/4 to the negative third power. And then our y is 8 into the 2/3. So then 8 to the 1/3 squared. So this gives us 1/4 times, that's 2 to the negative 1 to the negative third power, excuse me. So that's just going to give us 1/8. And this is 2 squared, which gives us 4. So we just get that's 1/8. All right, and then the partial of f with respect to y is, all right, so this x term is constant. Our y, the derivative with respect to y, then is 2/3. So x to the 1/4 times 2/3 y to the negative 1/3. Partial of f with respect to y at 16, 8 equals 16 to the 1/4, which is 2. 16 to the 1/4 times 2/3 times 8 to the negative 1/3. So that's 8 to the 1/3 to the negative 1. So it gives us 2 times 2/3 times 1/2. So this gives us 2/3. Okay, so now we have everything we need to substitute into the right hand side over here. So that tells us that f of, what was our point, 16.05 comma 7.95 is approximately f of x naught y naught, which was 8, plus f sub x, which is 1/8, then times x minus x naught. Make sure you do x minus x naught, not x naught minus x, because that order of that does matter, of course, because that's going to change your sign. So make sure you're always doing x minus x naught. So if you specify early on what your x and your x naught are, then you won't have any issue there. So 16.05 minus 16 plus 2/3 times 7.95 minus 8, and that will be our approximation there. And you could simplify that more, just because these, especially because these both work out to be the same thing, with the exception their sign is different. But that's sufficient right there. All right, so next let's look at number 24. All right, number 24 says, suppose a gas station has an underground tank in the shape of a rectangular parallel pipe that measures 10 feet by 8 feet by 6 feet, with air of at most 0.005 feet in each measurement. If the tank is filled with gasoline costing $10 per cubic foot, estimate how much the cost of gasoline can vary from $4,800. All right, so they want us to estimate how much the cost of gasoline can vary. So that's telling us that they want us to do a differential, because they want us to look at the approximate the actual change in cost. So we're not going to find the actual change in cost. We're just going to approximate it using a differential. So we can look at, first, we need a function to consider. So cost is a function of volume. So we'll say C of XYZ is equal to 10 times the volume, or 10 times XYZ. They said it costs, because they said $10 per cubic foot. That's why it's just 10 times the volume. And we'll just say X is length, width, and height. Y is width, and Z is height. All right, so they're asking us to approximate C of, so the length, we'll say, is 10 plus some change in, X, sorry. That's changing that. Well, I could have left it as Z, but that's an X right there, sorry. And then what was the other one? 8. So they gave us that the length was 10, the width was 8, and we're calling that Y. And the height was 6. So the costs at this, with these measurements, minus the cost at those measurements, they're telling us to approximate this. This is the actual, this right here is the actual delta C. That will be the actual change in cost. But the actual change in cost is approximated by the differential. So they're just asking us to find this. So so they want us to find this, where DC is equal to the partial of C with respect to X, evaluated at 10, 8, 6 times dx plus the partial, I don't know if this is going to fit here, plus the partial of C with respect to Y at 10, 8, 6 times dy. And we have to go down here, sorry, plus the partial of C with respect to Z, excuse me, at 10, 8, 6 times dz. And remember, dx, dy, and dz, if you remember from our previous video, either where I introduced the differential or where I drew the picture of what the differential is doing, or what you're getting when you're talking about the differential. Dx, dy, dz, that's the same as delta x, delta y, and delta z. So they gave us that. So, and dx equals delta x, which was 0.005. dy was delta y, which is also 0.005. So usually on a problem like this, a lot of times on a problem like this, these will all be different. It just so happens they gave us the same thing for dx, dy, and dz. So don't think that has to be the same in general for problems. All right. So now we can take all this and put it into this formula. We need our partials to put in first. So we'll just find those partials and then we'll substitute everything in. We could find them. They're easy partials, so we could find them as we put it in, but let's just write it out. So C sub x equals the partial of this with respect to x is 10yz. C sub y, partial of this with respect to y is 10xz. And C sub z, the partial of this with respect to z is 10xy. All right, so now we can substitute everything into this formula and we get dc equals, so we're taking our y is 8 and our z is 6. So we're going to have 10 times 8 times 6 times our dx is 0.005 plus our x and our z. Our x is 10, our z is 6. So we're going to have 10 times 10 times 6 times 0.005, and then plus our x and our y times 10. So 10 times 10 times 8. 10 times 10 times 8 times 0.005. I think we can simplify this fairly easily. So this equals, they all have a 0.05 in them. If I take the 10 and the 0.005, that's 0.05. I can factor out from every 0.05, sorry. We can factor out from everything, which leaves us with a 48 here, plus here leaves us with a 60, so 108, plus here it leaves us with an 80, so we get 188, so 0.05 times, 0.05 times 188, which is, what is that? So that's the same as 0.5 times 188 times 0.01, which is 9.4. So the actual change in cost is approximately $9.40. Is that what that was? Estimate how much the cost of the gasoline can vary from 4,800. Yeah, so the 4,800 is not something that, regardless of how much I'm not sure why they put that in there. So regardless of what you were starting with, the 4,800 must be if you put in these numbers that they gave us, the 10, 8, and 6. Yes, I presume that's what that 4,800 is, but yeah, depending on this particular volume. So yeah, that's what 4,800 is. So that's what corresponds to we did use it in our calculations, but we didn't explicitly need to use it. It's just what corresponds to 10 eighths is C of 10 8 6 is 4,800, because it's this is probably a better thing to use, 10 times 10 times 8 times 6. So our answer would be $9.40. So one thing I didn't make mention of, but notice that the differential formula is the same as the tangent plane approximation formula. It's just that we move a portion to the left-hand side. So this is separate from this problem. So if you have your tangent plane approximation formula, f of xy is approximately f of x naught y naught plus f sub x at x naught y naught times x minus x naught plus f sub y at x naught y naught times y minus y naught. If you take this f of x naught y naught and you move it to the left hand side, it just gives you that f of x y minus f of x naught y naught is approximately equal to all of this. So f sub x times x naught y naught x minus x naught plus f sub y x naught y naught times y minus y naught. This is an actual change in z. So that what you see on the left hand side is exactly delta z. And this says that delta z is approximately equal to this thing, but this by definition is what we have called dz or df. You may see it either one. You might see it dz or df. So that formula that dz equal, when they say the differential, dz is that thing. And remember, I told you all that dz is an approximation of the actual change in z. So that's why those are that's why we use one. They're introduced in the same section because this and dz equals that come from the exact same formula. All right, so that concludes section 13.7, and we'll start section 13.8 in our next video.